Hi students, I am SIDDARAMREDDY, lecturer, AC Independent PU College, Bangalore. So this is third session of power electronics and its applications. Last session we discussed about power transistor and SCR construction and working. So today's session will start with derivation of anode current. So before going to that, we'll briefly explain about SCR. So SCR, it is unidirectional thyristor. So it means it is semiconducting material, contains 4 layers, 3 junctions and 3 terminal device, which is used for high power switching applications that we call it as silicon controlled rectifier. So this silicon controlled rectifier is mainly used for power control, power conversion and rectification purpose. So last class we discussed about construction and working of SCR. So first, SCR, it is generally known as unidirectional thyristor. It's a semiconductor material, contains 4 layer, 3 terminal, 3 PN junction device used for switching applications. Coming to the construction. So here it contains 4 layers P, N, P, N and 3 junctions J1, J2 as well as J3 and 3 terminals anode, cathode as well as gate terminal. This is all about construction of SCR. This SCR is used for mainly 3 purposes. One is said to be rectification, second one power control and third one power conversion. Now we'll move to working of SCR. So before going to that, note this point. Here anode terminal of SCR must be connected to, this we call it as anode terminal. This we call it as cathode terminal. Anode terminal of SCR must be connected to positive terminal of battery and cathode terminal of SCR must be connected to negative terminal of battery. So here there are two cases arises. One is said to be gate is kept open. Case 2, when gate voltage is applied. First one, let us consider case 1, when gate voltage is kept open. So it means voltage applied between gate and cathode terminal is said to be 0. That is said to be voltage applied between gate as well as cathode equal to 0 volt. That we will call it as gate is open. When gate is open, this SCR, it looks like NPN transistor with open base. This gate terminal acts like a base terminal. When gate is open, it contains two transistors. One is said to be PNP transistor, other one is said to be NPN transistor. This is base terminal of NPN transistor. When its gate is open, that is nothing but B is said to be open, that is base terminal is open. When base terminal is open, no current flows through NPN transistor. Therefore, the current flowing through SCR, that is anode current, is said to be 0. When gate is open, anode current is said to be 0. Therefore, SCR is said to be off state. Whenever, if you increase this voltage, that is voltage applied between anode and cathode, when this voltage increases, fraction of time period, junction J2 breaks. When junction J2 breaks, SCR starts conducting heavily. The voltage at which SCR starts conducting heavily, we call it as breakover voltage. That is without gate voltage. That is gate voltage is said to be 0. If we increase that voltage applied between anode and cathode, within fraction of time period junction J2 breaks, SCR starts conducting heavily. That we call it as breakover voltage. So explanation of this is mentioned in the slide. Please go through the slide. Now we'll move to the second case, that is gate voltage is applied. That is gate voltage applied with positive voltage. So here gate voltage is applied, that is Vg is applied. When Vg is applied, electrons from N region move towards P semiconductor. As a same type, holes present in P move towards N semiconductor. As a result, gate current increases. So which generates gate current. When gate current increases, so more number of electron holes are appear at junction J2. So as a result, anode current of SCR increases. So as a result, anode current of SCR increases. So anode current increase nothing but what? SCR is said to be on state. So case 1, gate is open. When gate is open, SCR acts like a off state. When gate is applied, anode current increases. It means the current flows through load resistor. So that is said to be on state. SCR is said to be on state. Once SCR starts conducting, the gate terminal, it loses its control. So when gate current loses its control, the conduction does not stop at all. If you want to stop the conduction, we have to remove voltage applied between anode as well as cathode. When voltage applied between anode and cathode removes, then it stops the conduction. This is second case when gate is applied with positive voltage. These two cases are working of SCR. Explanation of this is mentioned in the slide. Please go through the slide. Now we'll move to the derivation of anode current by using two transistors, that is PNP as well as NPN transistor. Now this is said to be derivation of anode current. There are two cases, gate is open, gate is applied. So there are two cases arises here. Anode current is different for gate is applied as well as gate is removed. We'll see one by one. So in this diagram, this is construction of SCR. So here it contains three junctions. This we call it as J1 and this we call it as J3 and this we call it as J2. This is J2. So and junctions J1 as well as J3, junctions J1 and J3 are forward biased. Junction J1 and J3 are forward biased and J2 is reverse biased. Junction J2 is reverse biased. So here we are using two transistors. One is said to be PNP transistor, other one is said to be NPN transistor. This is circuit symbol of PNP transistor and this is circuit symbol of NPN transistor. This current we call it as emitter current. emitter current of PNP transistor is nothing but anode current. Emitter current of NPN transistor, that is, we call it as cathode current. So this I will mention it as IE1, this I will mention it as IE2. So here this bipolar junction transistor we already studied in first PUC. The collector current, the current flowing through transistor, it is due to majority charge carriers as well as minority charge carriers. If you consider PNP transistor, I will consider this as transistor 1. This I will consider it as transistor 2. If you consider transistor 1, this is transistor 1 expression here. The collector current, that is current flowing through collector terminal of PNP transistor, which is given by the current flows due to majority as well as minority charge carriers. Majority as well as minority charge carriers. So that is given by IC equal to alpha IE plus ICO. Alpha IE is nothing but due to majority charge carriers. If you consider PNP, IE1 is nothing but IA. This is due to minority charge carriers that we call it as reverse saturation current or leakage current. That I will mention it as ICO1. ICO1, it is leakage current of PNP transistor. As the same type, if you consider second transistor, in second transistor, IC2 is equal to alpha IE plus ICO. IE is nothing but IE2. In case of NPN transistor, that is IE2. IE2 is nothing but what? It is IK. Therefore, IC2 equal to alpha 2 IK plus ICO1. Sorry, ICO2. Here ICO2 is due to minority charge carriers that we call it as reverse saturation current or leakage current of NPN transistor. Alpha 2 IK is nothing but what? It is alpha 2 is nothing but what? It is a current gain. Alpha 1 as well as alpha 2 both are current gains of PNP as well as NPN transistors. So IK, that is cathode current. IA, that is anode current. So now from this figure, I will consider this as third figure. From this figure, IE1, what is IE1? IC plus IB. So that is IE1 equal to IC1 plus IB1, where IB1 is nothing but IC2. The same current flows through collector terminal of NPN transistor. That is IB1 is nothing but IC2. Therefore, IE1 is equal to IC1 plus IC2, where IE1 is nothing but what? That is IA. So replace IE1 by IA. Now substitute value of IC1 as well as IC2 from equations 1 and 2. From these two equations, substitute value of IC1 as well as IC2. This is IC1 and this is IC2. Substitute IC1 as well as IC2. Then equation becomes IA is nothing but what? IE1 is IA. IA equal to alpha 1 IA plus ICO1. So same type, IC2 is nothing but alpha 2 IK plus ICO2. Call this as equation 3. Now from figure, or we know that IK, this IK is given by this current as well as this current. That is IK equal to IA plus IG. What is IG? That is gate current. IK cathode current. IA anode current. Call this as equation 4. It may be case 1 or it may be case 2. Up to equation 4, that is same. Now consider case 1. What is case 1? Let us consider gate terminal is kept open. Gate terminal is kept open is nothing but what? Ig equal to 0. Case 2, when gate is applied. So it means there is a gate current. Now we'll move to next slide. So in this slide, case 1, gate is open. So it means gate current is equal to 0. Now substitute that gate current in equation 4. What is equation 4 here? Ik is nothing but what? Ik equal to Ia plus Ig. Ik equal to Ia plus Ig. Now substitute Ig equal to 0. When Ig equal to 0, so Ik becomes Ia. So now substitute this Ik value in equation 3. So equation 3 already we know that this we call it as Ik. So now substitute Ik value in equation 3. Ia equal to alpha 1 Ia plus ICO1 plus alpha 2 Ik. Instead of Ik, substitute Ia value plus ICO2. Now take Ia common, all Ia one side, take it as common. When Ia equal to common, 1 minus alpha 1 plus alpha 2, I will minus as a common. 1 minus of alpha 1 plus alpha 2, which is equal to remaining terms, that is ICO1 as well as ICO2, and Ia equal to, so now take this to this side, Ia equal to ICO1 plus ICO2 divided by 1 minus alpha 1 plus alpha 2, where ICO is nothing but what? ICO1 plus ICO2. This is case 1. In case 2, gate current is applied. When gate current is applied, then equation 4 is Ik equal to Ia plus Ig. So there is a gate current. When gate current is applied, then equation 4 becomes, instead of Ik, substitute Ia plus Ig. Equation remains same. So here we consider Ia because Ik equal to Ia. In this case, Ik equal to Ia plus Ig. Now substitute Ik value. Then equation 3 becomes Ia equal to alpha 1 Ia plus ICO1 plus alpha 2 into Ia plus Ig, because Ik equal to Ia plus Ig plus ICO2. So same type, take Ia common. Let us consider Ia one side, this term as well as this term, take it one side. Ia equal to 1 minus of alpha 1 plus alpha 2. Ia is common. So remaining terms, alpha 2 Ig plus ICO1 plus ICO2. Then next step, Ia equal to, so now consider all these terms one side. So take these terms into other side. Then equation becomes Ia equal to, this is remains same. So alpha 2 Ig plus ICO. What is ICO? ICO1 plus ICO2. If we take this term other side, that becomes divide. That is alpha 2 Ig plus ICO divided by 1 minus of alpha 1 plus alpha 2. Call this as equation 1. Call it as equation 6. Now equation 5 as well as equation 6, which gives expression for anode current. Equation 5 is expression for anode current when gate equal to 0 ampere. This is equation for anode current when gate is applied. Now this is all about expression for anode current. Now we'll move to VI characteristics of SCR. So this is VI characteristics of SCR. There are two characteristics. One is said to be forward characteristics and other one is said to be reverse characteristics. One is forward characteristics and second one is reverse characteristics. So this is first one forward characteristics and second one is reverse characteristics. So forward characteristics nothing but this we call it as and this we call it as forward characteristics of SCR. This is first one and this is second one, reverse characteristics of SCR. So first thing, forward characteristics nothing but a graph which represents relation between anode current as well as anode to cathode voltage, that is VAK. So it is a relation between the graph which represents relation between anode current as well as anode to cathode voltage for a constant gate current. This we call it as forward characteristics. So in forward characteristics, SCR conducts. In reverse characteristics, SCR does not conduct all. So it means it will withstand some maximum voltage. Now, so here, case 1, let us consider gate equal to 0. Gate current equal to 0. When gate current equal to 0, when you increase VAK, so initially it is said to be almost 0. When the voltage applied between anode and cathode reaches breakdown voltage of junction J2, from that point it starts conducting. So it means that voltage we call it as breakover voltage. When gate current equal to 0, when VAK increases at a particular state, SCR junction J2 breaks and it starts conducting. So it means anode current increases. That we call it as on state. SCR is said to be on state. It means it starts conducting. That is case 1. Next case, when IG is applied. So IG applied is nothing but what? That current is greater than 0 ampere. So here I consider three cases. Case 1 IG equal to 0, case 2 IG1, case 3 IG2. So here IG2 is greater than IG1, which is greater than 0 ampere. When gate current increases, anode current also increases. At that point, junction J2 breaks earlier compared to previous case. From this point, it starts conducting. As the same type, from this point, it starts conducting. So here, this point we call it as latching current. So this we call it as holding current. So latching current is nothing but minimum anode current required to turn on SCR when gate current equal to 0. So what is latching current? Minimum anode current required to turn on SCR when IG equal to 0. That we call it as latching current. Holding current is nothing but minimum anode current required to turn on SCR when gate is applied. That we call it as holding current. These two are very important. Examination they will ask for 1 mark. Please note this point. In reverse characteristics, SCR does not conduct at all. So it means it will withstand some maximum voltage. That is reverse characteristics of SCR. For your syllabus, this forward characteristics is very important. This is forward characteristics and this we call it as reverse characteristics. Reverse characteristics, SCR does not conduct because anode is connected to positive terminal of battery, then only it conducts. If it is reverse characteristics, it does not conduct at all. So it means it will withstand some maximum voltage. This is all about characteristics of SCR. So next class we'll discuss about other power semiconductor devices, that is power devices. Okay, thank you so much.